Hello, everyone.
Hello.
Hello. Hello. Welcome to our class. Today we are gonna go over our course, and of course we are gonna have the first lecture, and since it is extended, so we'll have lecture, lab, everything. Just keep in mind, lecture and lab, they are all the same. I am doing programming. I'll share the screen, and would you please open your Canvas account on this course so we can go through it together? Ready? Here, when you go to first thing is my announcements. In this announcement, you may see that we need to download this Arduino IDE file. This is the link to download this free software that we'll be using. You may start downloading it now. And the second thing is the kit, the Arduino kit that we'll be using. It is called Circuit Playground Express. This one, I gave you the link, so you may order it from DigiKey or Amazon, whatever you like. And we need it as soon as possible because we're going to be using it over and over. Any questions about those two?
So you're saying we won't need that kit today because mine won't arrive to the 5th.
Just a moment. What's your question?
Mine will not arrive till the 5th, October 5th. Is that going to be soon enough?
Arriving October 5th. Oh, you have placed the order and it's arriving October 5th.
That's correct.
Not earlier. Okay. Anyway, you have to order it and try to get it as soon as possible. I'm going to keep that in mind in my assignments. Let's go to the assignments and see our deadlines. We have the assignments here, as you may see. Each topic has certain assignments, and I can see topic 1 assignment. This is the first one. It is October 9. Mainly, we have topic assignment. We have 5 topics, and each topic will have its own assignment. And those would worth 50% of the grade. In addition, we are going to have each week, we are going to have some in-class activities. In-class activities means as we are explaining, I'm going to ask you to do certain programming, certain functions. And when you do it, okay, you are going to get the grade for it. this will be 30%. The last 20% will be for group projects. We are going to have 2 group projects. Group project mean a group of 2 or 3 are working together to develop something. And of course, after developing whatever they are going to develop, they are going to present it or report it. So we have 3 items: topic assignments and in-class activities and group project. In-class activity are going to have some trouble with it because it is October 2nd. So I'm going to change it for you and make it October 9th. But October 9, you will be having 2 assignments to do. So I changed the deadline for week 1 in class participation to October 9. We have topic assignment, in class activities, and finally group projects. The main part of our activities will be in the modules. What do we have in modules? Each module, I am giving you a PowerPoint, this PowerPoint for each module. Each module, we have 5 modules. And sometimes I have the in-class activities included inside the module. And there could be another one separately from the PowerPoint as this one, in-class activities. Topic 2, all in-class activities are within the PowerPoint. Topic 3, no, this one will have in-class activities in addition to whatever is stated in the topic. Those are my topics. And this will give you information about the projects. Project 1 and Project 2. Those are the assignments in addition. I am giving you sample programs that may help you understand what's going on in your project. So we have 2 projects. One, it's about clock and timer, using the clock and timer. And the other one is to run a motor using your Arduino kit. Now I am going to go to my lecture on topic 1. Is it all clear so far? The structure of our course? And of course, we have our syllabus right in here. You may go through it. I don't have a textbook for this course. And as you have seen, we don't have a midterm or final. Just topic assignments, in-class activities, and 2 projects, 2 group projects. We are going to give in topic 1 that is just an introduction to microcontroller. Before I continue, would you please, in the background, download the software I mentioned? It is in my announcement. the IDE software, please download and install while you are speaking, because we are going to need it. In this class, it is just a programming class, but we are programming a microcontroller, and we're going to speak about what is a microcontroller. But since this is a programming class, we are going to have many programs. The more programs you do, the more efficient programmer you will be. So I urge you, of course, to attend all classes. And in addition, I'm going to have on Monday morning, I'm going to be available for you for 40 minutes, 7 to 7:40. Do you have any classes or any clashes with 7 to 7:40? It is just, I'm going to be there for your questions. If you haven't completed any assignment and you want to have me beside you while you are doing it, I'm going to be there. Would that be okay with anybody? Do you have any clashes? Monday, 7 o'clock for 40 minutes, 7 to 7:40? No? Okay. And of course, I urge you to watch the deadlines of the assignments. So we are going to have many assignments. If you miss one, those will pile up on you. And as I said, we are going to have weekly participation points. This participation point is based on the in-class activities, the in-class programs that we'll be doing. So it is not by attendance, it is by in-class activities. As I said, we don't have any midterm or final. And we'll try to finish most of the in-class activities within the class time. Hopefully, the topic assignments also will try to do it within that time, but that is not going to be easy in all cases. Some topics, they have many programs that cannot be done within our few hours. As I said, the group project, we're going to have 2 or 3 working together on a group project. I suggested 2 topics, one for project 1 and the other for project 2. And I have given you supplementary material for those. If you want to have your own project other than those 2, no problem, you can do it. But you need to discuss it with me first. Cheating, you know what's about it, and academic dishonesty. So I expect from you outside the class is to complete whatever you are missing and to start building your reference sheet, syntax reference sheet. In every class, in every meeting, we are going to learn new instructions that can be used in your Arduino programming. Arduino programming, it is very similar to C, programming in C. And I know that most of you had this course in C programming. So this Arduino programming should look familiar to them. But still, when I communicate with this Arduino kit, I need to know extra statements. Like, for example, how to turn on a light emitting diode, how to use the microphone, how to receive data about the temperature, outside temperature. Those who are going to learn new statements. So I urge you to build your own syntax reference sheet. You have a reference sheet. In this sheet, you write the new statement and where you saw it. I saw it in topic 1, slide 10. So you write that. So this will be your reference. If you need to read the temperature, you know where you can find it. This is very, very important. During the class, we will be working together. I'm going to explain a topic and I'll let you work on it. And this will be the in-class activity. Most of the in-class activity, you don't have to turn in anything, but if need be, you will be uploading a PDF file, one PDF file. Suppose that we gave 4 programs. All 4 programs, what you need to do is to get a screenshot of the code itself, the program itself, and the output results. Add them to your one PDF file. So each in-class activity will be submitted in one PDF file. Any topic assignment, it will be again submitted in one PDF file. This is the Playground Express microcontroller that you can get. I give you here the Amazon, and on the announcement, I gave you DigiKey. You can get it from anywhere. I believe it is less than $30, and just try to get it as soon as possible so you can cope with what I'm saying. We cannot run any program without them. We have to have this kit to run any program. Some of you might have different kit. I believe you might have Arduino Uno. You can use it, but the ports, the address of the ports might be different, so you need to take care of that. But the examples I am giving, most of them are for this Arduino Express. So we need, of course, laptop and install the software, and of course, you need to be writing your own notes. The topics we are going to be dealing with is knowing the microcontroller and getting to know our software, the Arduino IDE. And of course, we need to know the history of programming and the types of programming language and where Arduino lies within the big family of programming languages. So here, we need to have a good attitude. A good attitude means doing the assignments in time. And of course, you need to be willing to give the effort to this class. All in all, it is easy, but still, it is a demanding class. Now we are starting topic 1, and the objectives of topic 1, we have 5 objectives. First, we need to know why computer programming is valuable to engineering as an engineering tool. Explain the difference between binary assembly codes and low-level, high-level programming languages. I said we have a big spectrum of programming languages. Within this spectrum, we have our C or Arduino IDE software. And you need to know different parts of the kit that you're going to have, the I/O pins, the capabilities of this kit, and describe it. And describe the difference between what's called a microprocessor and a microcontroller. We are speaking about a microcontroller that we are going to be using. How does it differ from microprocessor? We are going to speak about that in this objective, and we'll explain it. We'll build one program. It's called the Blink-LED program. In this topic, we are building a very small program, but we are going to make some modifications to it, but it is still one program, and it is given to you. The first objective, why do we need computer? To know that, you need to know what the difference between data and information. If we say that I have the date of birth of all of you, this is data. But information, it is to process the data and know what is the average age among you. Who is the oldest? Who is the youngest? This is information, processing the data. Computer programming is to take the raw data and process it and give you information. For example, I can get the temperature over the past 20 years. Now I have a lot of data. Can I use this to predict the temperature of the coming 3 months? Yes. I can do processing, I can get the average, I can predict what will be the temperature, average temperature over the coming 3 months. So I moved from data to information. Computer strength is speed. Of course, the speed, we measure the speed of the computer in what is called million instruction per second. How many million instruction per second can this computer do? Addition is one instruction, subtraction is one instruction. So it is measured in million instruction per second. And of course, accuracy. Accuracy, it is another merit of the computer and another strength, and consistency. It doesn't forget. If you search for the youngest and you search again, it will give you the same person, who is the youngest person in class. Reliability, I mean, you can rely on the data coming out of it, the information. It doesn't need any sick leave or coffee break. It is reliable. Whenever you need it, it is there. Just work on it. It gives you a great communication. You can communicate through networks of computers. And of course, it has almost unlimited memory. All of those are strengths of the computer. The hardware of any computer system will be CPU, Central Processing Unit. This is the brain of the computer that controls everything that's happening there. And in addition, I have the main memory, random access memory, and read-only memory. I believe most of you had digital 1 and digital 2, so you know what I'm speaking about. And I have the secondary memory, that is hard disk, flash drive. Those are secondary memory. Now I will stop here and start asking you. We know the RAM and we know the hard disk. What is the difference between RAM and hard disk? Both can store data, but what is the difference? Eric? Hello, Eric?
Hello, can you hear me?
Hello, hello, hello. How are you this afternoon?
Good, I'm doing okay.
Okay.
Well, let's see. I'll give it a shot then. The hard disk is for long-term storage.
Yes.
Stores data that you need for long duration. And then your RAM is for short-term memory that you're using actively.
I would translate that in saying that as long as the computer is on, the RAM will retain the data. If you turn it off, it is lost. That's why it is short term. Hard disk, if the computer is off, the data on the hard disk will remain there. It will never be erased unless you erase it. Just give me a moment. I need to get my charger. Thank you, Eric. Vesely?
Yeah, I'm here.
Yes, sir. Another difference between a RAM and hard disk.
RAM is more expensive than a hard space disk.
More sensitive?
Expensive, yeah.
Expensive, yes, yes. It is very expensive compared to hard disk. Stevie? Hello, Stevie? Steve? Steve is not available?
Yes, I'm here.
Oh, hello, Steve. Hello, Steve. Another difference?
First thing that comes to mind is the term dynamic and non-dynamic. The RAM is considered dynamic versus the long-term storage is non-dynamic. It stays in place.
What do you mean by dynamic?
It will change when you power on or power off the PC.
Oh, yes. As we said, when the power is on, I can have the data transferred from the hard disk to the RAM, or I can write to the RAM directly. Yes. Brandon? Hello?
Yep. Hello.
Yes, sir. Which is faster? Hard disk or RAM? For retrieving information. I put information on the RAM and I put information on the hard disk. Which is faster to give the data back to the CPU?
RAM would be considerably faster.
RAM will be faster. The hard disk works in milliseconds. That is very fast. But the RAM is working in micro and nanoseconds. Can you see the difference? Could be a million times faster than the hard disk. Van? Hello, Van? Van is here? Are you
Oh, yeah,
available,
I'm
Van?
here.
Yes, sir. Could you give me an application for the RAM?
I think it's used to store the short memory for the computer.
Yes. When you have a program that you want to run, the CPU, it is running extremely fast, very fast. So if I am gonna get the program from the hard disk and I take one instruction, computer, CPU, process, wait, and ask the hard disk to send the next instruction, that will be a huge bottleneck. We need to avoid it. So at the very beginning, I am moving my program from my hard disk to the RAM. The program that I am going to be running now, I'm not moving everything from my RAM, from my hard disk to the RAM, only the program that I'm using at this moment. I move it to the RAM because the RAM is much faster than the hard disk, okay? So I am asking whose turn is that? Benjamin?
Which band is it?
Ben?
Well,
Yes, Ben May, okay. Ben, if I have more than one program running simultaneously at the same time, what do I need? But I have one CPU.
One CPU, you talk about multi-threaded or like a single-threaded?
No, this one CPU, and I have many programs. I'm using word processing, and I'm using Excel sheet and MATLAB. All of those, I open them.
Okay.
How do I swap, change them? Are those all on the RAM?
Some depends. Depends on the capability of your RAM though. If you actually don't have enough memory, they would actually create like a swap file inside of your hard disk to move the program in and out of the RAM.
Okay, that's good. We are making a virtual RAM by taking a space from the hard disk and making it as a virtual RAM. But when we are running one of the programs, it will be in the real RAM, not in the virtual RAM.
Yeah.
Okay, excellent. Now I am going to ask Benjamin.
yes.
Benjamin, can you tell me what is 65 times 71? What the result will be?
65 times 71?
Yes.
Well, can I use a calculator?
I'm still waiting for your answer. It is taking you
No
a long
offhand.
time. How are you going to do it?
Well, I'm using a calculator.
Or you can use a scratch pad.
4,750.
You can use the scratch pad and do it.
All right. That would take me much longer.
For the CPU, does it have a scratch pad?
That would be the RAM, right?
No.
No?
This will be the cache memory.
Oh, okay, got it.
The cache memory, it is just to store very few instructions. I want to add A plus B. So A and B will be in the cache. Just those. Cache is very, very fast, and it is within the CPU itself. It is part of the CPU. Sometimes I have extra cache that is outside the CPU. Again, it is going to be very fast, and it has a very fast link to the computer. I am really so impressed by your knowledge. All of your knowledge is quite fantastic. Now we go back to continue our lecture. Input devices, keyboard, mouse. Now we are going to see input devices like sensors. I am going to sense the speed, I can sense the temperature, I can sense the light intensity. The light intensity, I can sense it. And based on this information, I can decide on what I'm doing now is to turn on the light. Because we are getting close to sunset now. So those are input devices. In our system, we are speaking about industrial system, industrial application, industrial system. I can sense the speed of my production line. I can sense the presence of my job in place. I can sense many things. Based on that, I am going to give an output. Output, a command. Turn on the belt. Let the belt start moving. Increase the speed, lower the speed. Turn on the heater, turn off the air condition. All of those are commands going to the output device. And I need network interface. A network interface because I need to communicate with the network if need be. And all of those would need, of course, power supply. This power supply, I have 120 volt, but my computer system either working at 5 volt DC or 3.3. I'll stop here and ask Arturo?
Yes, I'm here.
Yes, sir. In most of the logic or microprocessors, those are either 5 volt or we can find nowadays many of them are working at 3.3. Why do we move from the traditional 5 volt to 3.3? Can you guess?
I guess to give a better range of inputs and outputs for different, to be LED lights or motors or the small objects or small controllers.
No, I speak about your Arduino. It is 3.3. I speak about many computers are having integrated circuit. That those are the new trend is 3.3. Does anyone know why we are moving from 5 to 3.3?
Power efficiency.
Anyone guess? Yes, Brandon?
Is it power efficiency?
Power consumption. Yes, power consumption. I am lowering the voltage because higher voltage, I will get more current. And whatever the electric circuit is, current is flowing into it. Whatever the circuit is, it has internal resistance, very small one, and I will have I square R. This is power losses. I am not using the heat that will be produced by the I square R to make tea or coffee. No, it is lost. And in addition, I need to get rid of that heat. So I am cooling my system. Extra cooling means extra money, extra operational cost. So that is why we are moving from 5 to 3.3. we are discussing these points because those are interview questions. When you graduate and you are in a job interview, you might be asked similar questions. Software, we have many categories of software. Firmware, operating system, application programs. We'll be doing application programs. Operating system, it is the program that is like Windows. This is how I communicate with my peripherals, how the CPU communicate with the monitor, with the keyboard. Firmware, those are produced by the manufacturer and I don't touch them, untouchable. And again, an example of that, the monitor itself, it can have a firmware little program built into it to communicate with the CPU. Now we are gonna go to objective 2, reminder of objective 1. We discussed the computer and why it is valuable as an engineering tool. And now I am moving to another one. It is the difference between different categories of programming languages. A programming language, it is just instructions, a group of instructions to ask the computer to perform certain tasks. And I'm asking the computer to do whatever the instructions are. And this is to communicate with the peripherals and the hardware to run and execute this program. And as I said, and as you said, when we are running our program, it will be moved from the hard disk to the RAM, or if I'm repeating it over and over, I can put it in the ROM, read-only memory. The CPU knows only what is called machine language. Machine language, it is just a code of ones and zeros. Every instruction, every letter, every number, it is coded in a group of 1 and zeros. So the CPU understands only machine language. It doesn't understand English. It doesn't understand C. It doesn't understand Fortran or BASIC. All of those are, or assembly. Those are languages that we as a human beings understand. And we need to convert these languages to the machine language.
Can we say that the binary code is the lowest form of code there is?
Yeah, the machine language is coded into binary digits. Each binary digit, the 0 and 1, it represents an instruction. It represents a number. Yes. The machine languages, it is ones and zeros only, binary. The memory, as we said, it can be ROM that we don't change. And this ROM can be part of the BIOS. This BIOS, it is made by the firmware. Firmware, it is by the manufacturer, but it is different than the ROM. BIOS, sometimes the manufacturer issues an upgrade, an enhancement, so I can have this BIOS to upgrade it. But ROM, once it is there forever. Secondary storage element, as we said, hard disk, thumb drive, CD, DVD, all of those are secondary storage. Very cheap, huge, but very slow. And updates, I can get updates through the internet, or I can communicate with the manufacturer to get any updates. Mobile application or application programs like web application, mobile application, leisure, educational, all of those are applications. For our system, we have something called embedded software. This is a new trend, embedded software. This embedded system or embedded software, it is like, for example, your printer. Printer is a complete system. Everything is embedded in there. It has its own CPU. All what it needs, it is an order from the computer to print data. So I'm going to get the print command, I'm going to get the data, I'm going to get the format to print it. Is it color or black and white? The margins, all of those, I get this data, and the embedded software in the printer will do the job. Cell phone, again, it is an embedded system, an example of embedded system because it is complete system. You are giving it instruction to show you the date, to show you your calendar, to retrieve your email. So it is embedded software that can do the job. It has its own CPU, its own RAM, its own hard disk. Everything is within this embedded system. As we said, the program, it is to process information. And we are implementing certain algorithms. The program is to do certain algorithm to achieve, those are my inputs and that will be my output. When we say it is written in high-level language, I need to translate it to a machine language. This translation, it is called compiling. Compiling a program, it is to translate it. So I start by a programming language, compiler to translate it. Now I am at a machine language. Here in the computer. The machine language is downloaded to the computer to use. Machine language, this is a very low level, but it is very fast. And for this, to communicate with my high-level language, I said we have a compiler. A compiler that takes my high-level code and translates it to a machine language. We have another brother of the compiler. It is called interpreter. Interpreter, it is different from a compiler. Does anyone know what is the difference between interpreter and compiler? Interpreter and compiler. Christine? Christine? Hello, Christine? No luck with Christine? I am here. Oh, we cannot hear you. So you have some problem with your mic? No problem. Okay. We go to Jordan. Hello, Jordan.
Hello.
Just one.
Any idea about the difference between interpreter and compiler?
I'm pretty sure an interpreter is just executing like a line of code, whereas a compiler is going to compile a whole program as opposed to just one instruction set.
Yeah. So interpreter, it translates one instruction at a time. Compiler, it takes the whole program and convert it to machine language, and it is ready. The CPU grabs one instruction at a time. Interpreter, it takes one instruction, convert it to machine language, computer will use it while I am translating the second instruction. That is Visual Basic. In Visual Basic, they use this interpreter. This is their technology. They use interpreter. Of course, it is much slower than the compiler. Thank you.
So what's the difference between, is it the same as like ahead of time and end time compiler?
The compiler translated the whole program, and I am leaving it to the CPU to do it on its own pace. Of course, its own pace, that means very fast. But with interpreter, the CPU has a bottleneck. What is the bottleneck? It is the interpreter. It is interpreting one instruction at a time. Still, it is being done in millisecond or microsecond, but the CPU is working in nanoseconds. Nanoseconds. So there is a huge difference in speed. Interpreter is doing one instruction, giving it to the CPU, doing it the second, third, fourth, and so on.
Thank you.
Thank you. Procedure-oriented language. I can make a procedure or a small program that will be used over and over, going modular. This procedure program, it is very good in solving problems. For example, I can create a function, sine function. This sine function, I give it 30, it will give me sine 30.5. So this procedure or program, this is something good. We have programs like COBOL. This is for business purposes. That is very powerful for accounting. Fortran, that used to be #1 for scientific and research, this Fortran. Ada language, that very old, and I'm going to leave you with some video links to know the history of computer and computer programming. This is a very good view of how the programming languages evolved. From very primitive until we have now object-oriented programming, and I'm going to leave this for you. Level of abstraction, high level language like Python, Java, C++, COBOL, all of those are high level. Basic and Fortran C, those are high level languages also, but this is an old version. The new version that will enable me to use object-oriented programming are those ones. Assembly language, this is a fast language, very fast language, much faster than any of those. And it is, of course, we consider it much higher than the machine language, but still not easy to use. Why? I have to ask it to do load A, grab A from the hard disk, put it in the memory. Load B, get B from the hard disk, put it in the memory. Now C will be A and B. In high-level language, I just tell it C equal A and B. It will go and grab A and grab B. But here in assembly language, I have to tell it what to do. But still, assembly language is much closer and much faster than the machine language. We'll be using Arduino, and this is a C-based language. Arduino is part of the C language, and almost all the commands are based on C. Describe the parts of an Arduino and different types of I/O pins found on the one we are going to use. I am going to give you now a break for about 15 minutes, and we'll be back at 6:45. Okay? We'll stop here now. Hello, we are back. We are in our third objective. This is to explore the board that we are going to be using. Have you downloaded my PowerPoint? Please go to this website. In this website, it gives you information about the Arduino Express kit, specs of it, it will be for you to read. I'm going to give you time to read. This one, another very important link. It identifies the main elements, the main components, the processor, the sensors, everything is described in here. Speakers, sensors, all kinds of sensors. This is the layout and the different pins that we are going to be addressing, input outputs and their addresses. We have here slide 36, 37, 38. I want you to start reading them now because this is going to be part of the topic. Let me go back to Halo. Assignment. The first topic assignment the assignment is in the syllabus. Topic 1. Topic 1. This is the program you will be doing. Describe the difference between microprocessor and microcontroller. We are going to speak about this in a moment. Understand your Arduino. This to describe the functionality of the board. And for this one, we need to understand the links on 36, 37, 38. I am going to give you 20 minutes to go through those so we can discuss them together. Okay? 20 minutes. Hello, everyone. Hello.
Hello.
Are we ready? Have you read those 3 slides, the links of the 3 slides?
Yep.
Yes.
Okay. Let me share the screen and start discussing one by one. I believe this is the first one, overview. And in this overview, speaks about our kit and the maker, and speaks about the features. And I need to have you speak to me about it. Vasily?
Yes.
Would you tell me more about different input outputs as you read it?
Yeah, so basically this board has a couple inputs, two buttons, a temperature sensor, a motion sensor, and also you can connect more inputs on the outsides of it. And the outputs are LEDs. You can also connect devices to output a signal, and then you have a speaker as well to output a noise if you want to trigger that.
Okay, very good. Eric? Hello, Eric? Is Eric available?
Yes. Can you hear me?
Yes, I do. Would you tell me about the sensors? How many sensors? What are those sensors? Forget about the number. Just tell me what are those sensors that are available?
It has the motion sensor, which is an accelerometer telling you, you know, the change in direction and change in acceleration for that.
Yeah.
It has a thermistor, which is the temperature sensor, a photo transistor for sensing changes in light and
light
and,
intensity.
Can you repeat that?
Light intensity.
Light intensity. We used a color sensor and pulse sensor. Has a microphone for as a sound sensor. And then it has 2 push buttons and 1 switch, slide switch. It has that's most of the
No, I'm just
sensors.
asking about the sensors. Thank you very much. Steve?
Yes.
How many LEDs do we have?
There's I believe that's
number of LEDs, light emitting diodes.
13. Is that right? Or,
you read it.
Oh, that's the pin 13.
Okay.
There's 10 color NeoPixel LEDs.
10 programmable LEDs. Yes. Okay. I think that is, let's see it one more time to see if I've missed anything. Oh, we missed something very important. Jordan? Jordan?
Yeah, I'm here. Yeah.
Yes. How many I/O ports do we have? Input-output ports that we can program, that we can access?
Yeah, it looks like we have 8 general purpose ones, and theoretically you could get 1 more if you did some fancy stuff, but eight of them in general.
Yeah. do we have any analog input output?
Yeah, I think all of these can do analog input, but there's only one that can do analog output, as in not PWM, but just analog.
Okay, so we have analog input outputs available. Okay.
Yeah.
Okay. Now let's share the screen and see what's next. The next slide learning the system, that it gives you allocation of all what we have said. Where are those push buttons? Where is the CPU? The microphone, where is it located? The analog output, this is the analog in output. With this sign, it means analog. It describes also the power and data, the USB connection, where it goes, and if I need to add a battery so that it can work standalone, I don't have to be connected to the computer at all. It will come with a battery connection and battery compartment. And those alligator clips pad, those alligator clip pads, I can connect my Arduino to the outside world through those alligator clip pads. This is my brain, the microchip. We have many LEDs. Green, that is to tell us that the power is on. And number 13, that is the one we are going to use in our first program. It is a programmable, and we are going to use it. And we have, in addition, 10 other programmable, and those 10 programmable, I can even program their color. But pin 13, it is just one color, red. But the other 10, along the perimeter of my kit, those are programmable. Description about the speaker, and it is not huge speaker, but it's very tiny one. And those are the sensors that we have, a description of all of those sensors. And some of the pads are capacitive touch. If I want to make a light dimmer, I can use this capacitive touch. Switches, slide switches, infrared receiver transmitter, the next slide is pin out. In this pin out, it tells you the pin number that I'm going to use to program it. If I want to program the red LED, red light emitting diode, it is number 13. So I need to tell my Arduino, my program, turn on 13. This is my LED. So we need to have this handy because it tells us where each LED is and the address. Now I'll go to my syllabus to check again one more time about my tasks. If you go through the syllabus as I'm going now, this is the course objectives, and this is my topic 1, which you are studying. Those are the objectives that we are speaking about. We reached number 3. Now let's see our tasks. We need to run this blinking an LED. This will be doing. For each topic, we have assignments. These assignments are the topic assignment that would worth 50% of the total grade. Topic assignments. The first one, update your board. This has 0 points. Blinking LED, this is the program that we are going to see and describe, and you are going to run, of course, and I need to see it running. Describe the difference between microprocessor and microcontroller. This is an essay, and we're going to speak about it briefly here, but you are going to expand on it. So my first assignment, blinking an LED. Number 2, describe the difference between microprocessor and microcontroller. Number 3, understanding your Arduino. Understanding your Arduino, it is mainly the 3 slides we discussed right now. That's all what we need. This is the topic assignments, 3 parts. Now let's go to my slides. This is the difference between microprocessor and microcontroller. Microprocessor. Microprocessor, it is an entity by itself. It can do all the control of a computer. It can control the computer. It can do the processing, making all the arithmetic and the logic of the computer. And we need it for what? Everywhere. Everywhere you can find digital controller, you can find in electric power system, smart grids that is based on computers and microcontrollers. Electric vehicle, it's an example of embedded system. This microcontroller, it is the heart of all of the electric vehicle. It coordinates everything. The motor drive system and the battery management system and the communication, inputs, outputs, all are controlled by this microcontroller. We have many types of microprocessors and microcontrollers. This base, it is digital controller. Field programmable gate array, it is another family. I believe we will use this in EE331 FPGA. Programmable logic controller, this is another version. And this is very industrial because in addition, it has many input outputs. It has very compact system. It is designed to work in industrial environment. It can withstand more heat, more humidity. It is, to a certain extent, it is protected from dust. So this is for industrial application. And digital signal processor cards, all of those are examples of embedded system. Now let's see the microprocessor and the microcontroller. This is the topic that you need to expand on it. Microprocessor, it is the CPU entity by itself, but it cannot work by itself. I need to add to it the RAM, the ROM, I/O ports, timer, and ports. So by itself, it means nothing. But I need to add all of those to make a computer, to make a control system. So if you add all of those, it will be expensive. But here, this system can do anything you imagine because I am building the system according to my needs. So I can build a laptop, and this laptop can do word processing, it can do Excel sheet, it can do whatever you want, MATLAB. But what about the microcontroller? The microcontroller, it is a kit. It has everything, including the CPU. So the CPU, it is the central processing unit. It is part of a microcontroller. But here, I have everything assembled for me. All what I need to do is to program the input and output ports, use whatever I have, timers or sensors, whatever those are, and generate an output. This output to control whatever you want to control. But this microcontroller system, most of the time, when I develop it, I'm going to be developing it for certain application. For example, I can have the microcontroller system. I'm going to use it just to control my elevator. So I'm going to make the program and hook up all of the input and output ports to do this certain job. I can have the microcontroller system to control my microwave oven or your dishwasher. So I have certain programs and I'm selecting these programs to run on the CPU to do the dishwashing tasks. So again, this gives a briefing about the differences between microprocessor and microcontroller. I expect you not just to take my words, but to search. There are many articles that speaks about the difference between a microprocessor and microcontroller. Please look it up while you are doing the second task. The first task is blinking a LED. This is the second. The third, again, it is what we spoke about, the description of the Arduino board that you will be getting very soon. Now we go to Arduino. After installing Arduino, it is starting.
I have a question.
I have one more slide about the differences between microprocessor and microcontroller. Here it speaks about microcontroller can be 4, 8, 16, and 32 bits. This number of bits are the address bus. The address bus, more bits means I can have a bigger memory, I can have a bigger RAM, I can address more instructions with longer or more bits in the processor. The processor will be much faster as you go with the 32-bit. With 32 bits, I am capturing 32 bits simultaneously. Of course, if I compare it with 4, it is just grabbing 4. So these are the specs of a microcontroller itself. And now let me go to the blinking LED. In blinking LED, before I go into it, I would need to tell you that the program that we are making, any program we are making, it is called in the Arduino environment, Sketch. So when you read Sketch, it is a program. And the sketch or the program must be saved in a folder. Each program should be saved in a folder. The name of the folder should match the name of the sketch. The name of the program or the sketch must match the folder name. So I make subfolder, and in this subfolder, I put my sketch, I save my sketch. This is my program. Blinking and LED. If I give it this name, I should store it in a folder with the same name. Here we are building our vocabulary. As I said, we need to have a reference of all instructions. So here I am going to have so many instructions. And we're going to explain it one by one. The first instruction here, it is define. Pound sign, define. I am going to define, this is IO13. And according to the last slide 39, the reference 13, it is the red LED. So I'm saying this 13, I'm going to give it a nickname. LED underscore pin. This is the name I'm going to give it to this 13. And instead of using 13 and wondering what is it, I'm going to define this nickname for it. Then after I do that, I may use variables. The place to define the variables means I need to say if this variable will store whole numbers, that means integer, or fractions, that is real. Will it store logical, that is true or false, or what? So here I'm stating I am going to have something called state, and this state I'm going to say it is integer. So it can take whole numbers. After I write this, as in C, each statement must be terminated by a semicolon. My first statement, defining pin 13, I'll give it the name LED pin. Number 2, I am saying that I'm going to have a variable. This variable, it is called state, and it is integer. Then let me show you this. If I go to Arduino and I'm starting a new file, can you see the new file? How did it start? It starts with void setup, void loop. Any file or any Arduino file, this will be the starting. If you want to start a new file, I will have those two parts. Those two parts, the first part, I can put any code that will be run once. It will never be repeated. So anything between this left and right parentheses, anything I put in between here, it will be executed once. That's it. Why do I need the word void? Void means this function, which will be executed once, it will return nothing. It is a function, like sine, like cosine, but sine and cosine, you give it some input and you get output. This one will return nothing. This is what is meant by void. Void, that I am writing this function and it will never return anything. I can write other functions that would return. Okay? I can write, for example, a function that takes 10 numbers and give you the average at the return. But here, this will return nothing. Loop. This is another function returning nothing. But the characteristic of the loop is whatever you do here, after you end 10, 5, 100 instruction, when you reach the left parenthesis, curly parenthesis, it's gonna go back. It will repeat itself forever. Doesn't stop. Each function, left and right curly braces, and in between I put my instruction. Now, since we are here, I can also see examples. Those are examples that are for your system. If I go to basic, I am going to see another version of my analog blink. This is another version of the same program that I'm going to show you, but different. Here it starts with this backslash star, means everything will come until you hit the other backslash star. It is a comment statement. It is not executed. It is ignored by my compiler. When I have double slashes, means this line only is a comment statement. So now we know what is meant by group of comment statements or just one line. Again, here I have void setup and I have void loop. This will blink the LED. We're going to speak about this first because it is simpler, then we'll go to the other one. Here, what we have in the setup section, what did I define here? I defined pin mode. I have a pin. This pin is 13, but LED underscore built in, it knows I don't have to redefine it. Red built in, it means internally 13. It is an output. So I'm going to send 1, I can send 0 to this pin. So this is 13 will receive an output. I'm going to consider 13 as an output. I put this in the loop that will be executed once because I don't want to repeat it. Now I go to whatever I am going to be repeating. What do we have here, the instruction? Digital write. What is digital write? I'm writing to my output. Which output? LED built in. Red built in, that I defined it as an output. I am going to send what? High. I am going to give it the logic high. Okay, now the logic is high. Next statement, here is semicolon. Delay 1000. Delay 1000. Delay 1000 millisecond. That means delay 1 second. Digital write. After 1 second, I am writing low. Here, the LED was high, that is on. Now, the LED is low, that means off. Now I delay 1 second again. What will happen after I finish this? This is the left curly braces. It will send me back to the top and execute the same instruction again. Turn on the LED, wait 1 second, turn off the LED, wait 1 second, go back. This will be repeated and repeated. Now we need to run this. I have my board here. I am going to hook it to my computer. Now it is hooked to my computer. I need first to go to tools. Tools, I need to select my board. I go to board manager, and you start looking for the board you have. There are many over here. And whatever you need to install, just install. Of course, we are going to install our Arduino kit, the Express. After you do that, you should see it here, board Arduino Circuit Playground Express. This, you should see it. Okay. Step number 2. You need to know which port this Arduino is connected to. Here it says 5, so I'm selecting it. Now it knows what is my kit and what port is it connected to. Now I am ready to start my program. And starting the program, I need to do the process of checking the syntax, if there is an error or not. And if it is correct, compile this program or sketch. Number 3, download it to the RAM here of this Arduino. Finally, run it. All of this will be done in one step, just clicking here. If it detects an error, it will tell you that there is an error. Now it is done compiling and it is running. I don't know if you can see it clearly or not. The LED is turning on for 1 second and turning off for 1 second. On for 1 second and off for 1 second. How does this program differ from this one? This one, I need you to read it and then we can discuss it. Read it very slowly and then we are going to discuss it. Anyone wants to explain to us this program?
I'll do it. Someone else wants to.
Okay, go ahead.
So we do the same thing. We start by defining the pin 13, the pin number 13 as our name LED pin. Define a global variable integer state. Do the same thing.
What do we mean by global variable?
I mean that the scope of this variable is for both the setup and the loop, and all scopes inside of that.
Yes, global variable. If I say integer state within the void setup loop, it will be used only within this loop. But if I put it up here, it can be used by any function in the program, in the sketch. So this is a global one. Yes, continue, please.
And now at startup, we're setting it to 0, this global variable.
And the state, we are saying that initially it is going to be 0. Okay.
Yes.
Now we go to the loop.
Right. And now we're going to digitally write pin 13 LED pin to 0, which is low.
Digital write means write something to an output pin.
Yes.
Digital write, I'm writing something out. Digital write, here we are writing just one thing, one pin. But digital write can be writing a text to the monitor, as we're going to see later. But for now, I am writing, I have to tell it where to write, where will it write, and what will it write. Where it is the LED pin. This is the first argument. The second argument, what value it will be writing. It will write the value state, and the state, it was declared before here as 0. Continue, please.
Right. And then we're assigning not state to state. So we're changing it from a high or a low to a high.
Yes. This exclamation mark and the equal means assignment. Take whatever on the left-hand side, put it on the right-hand side, store it in the left-hand side. But here I am putting equal followed by this exclamation mark that means invert. Whatever the state is, inverted. So currently at this time, state is still 0. Now state will be 1. Now here I'm saying delay. What's meant by delay?
We're going to halt operation until the timer reaches 225 milliseconds.
Okay, it means, in other words, go and have a cup of tea and you have 2 to 5 milliseconds. 225 milliseconds, go and do whatever you want. This is what's meant by delay. Do nothing. Now, what will be next? Now I printed out 0 and the state, now it is holding 1. What will happen after the delay?
Now we're going to go back to that digital write, and we're going to write the new value of state.
Yes, we need to go back because this is a loop. We are going back, and the first statement we are going to hit one more time, digital write. Digital write what? The LED pin. And now I am printing or writing the state. The state is now 1, so it was going to turn the LED on. Now the LED is on. I go to state, invert it, it will be 0. Delay 225, wait 225 milliseconds, and go back now with state 0. And that would repeat forever. This is my system running forever. Running forever, doesn't stop. Any questions before we proceed? Any questions?
I do have a question, actually.
Yes.
Why does this sketch use an integer type instead of a Boolean type for state?
You can use it. Yeah, you can use it.
Okay, just either one works.
True or false. Correct?
Yeah, but doesn't that when you define like state different than state at the the bottom to last code, the last line. Isn't that would it just add one more or just a different integer instead of 0 or 1? For example, it was 0, and then now instead would it just randomly select a value instead of true or false, like he was mentioned earlier, that just a Boolean type.
Yes, Boolean, it is true or false. And here the integer by default, if just I am using it with this inverting command, inverting means what? Inverting, if I have, for example, a binary number, and it is one digit, and this digit is 1. If I say not 1, inverted, what will it be? It will be 0. Inverse of 1, it is 0. Inverse of 0, it is 1. So I'm saying I have integer, and this integer, I gave it 0. 0, it is just I have 1 bit, and this bit is 0. Now, if I invert it, it will be 1. I can use true, false, Boolean. It will work also. Both of them will work. But the inversion, this not, doesn't mean put negative sign. No. With integer number, I am flipping. If I have 1 0 1 0, it will be 0 1 1 0. This is the inversion of it. Yes, Boolean will work, and this one is working well.
I have a question.
Yes.
For the assignment, we have to prove that this worked. How are we supposed to submit that?
I have to see it.
So like we submit a video of it working?
No, no. When we meet, I'm gonna see it.
Oh, okay.
If we don't meet, then you will submit a short video.
Okay.
But if we are meeting, for example, if you had your kit with you, you could have run this in 2 seconds. You show me, that's it, done. You will get full mark for it, done. But when you get your kit, it may take time. We may not meet. So you have to submit a video. But it is easier that just forget about this assignment. In the coming assignments, all this participation exercises, it is a grade not for attending my class. No, it is to show me your programs running. You show me during the class, I'm gonna give you 5, 10 minutes, half an hour, 45 minutes in some big programs. We'll be doing all of those within our time period. And we are gonna share the screen, and you are gonna show me the program is running. Not all programs will have blinking LED, but others will be running and giving you an output to your screen. So when we share the screen, I'm gonna see the programs, and I'm gonna see what do we give to the as input and what you are getting as output. This is gonna be good for all of us, not for you only, because other people might be struggling, might be having another program code, another idea to achieve the same program. So it is a learning environment for all of us. Any other questions? This is another important link. This is the reference language. I think we are familiar with digital write. We have seen it. We have seen pin mode. Any one of those, if I click on it, it is going to send me to a detailed explanation of the function, how to write it. As you see, digital write, I should here put the pin and the value. Value should be high or low. It is Boolean, 1 or 0. So it is very important that you go through this reference to see the commands that you can use. Not all of them we are going to use, but at least you know that those exist and those are available for you to use. I think that is all that we need to do. Install the Arduino IDE, configure your board, blinking LED. You should demonstrate that to me. And I need to go here. To my modules and start reading the in-class activity. Please remember, let me show you again. Topic 1. This topic 1, I am looking for assignments. Assignments. Assignments here. I have update your board. You update it and it has no credit. Blinking an LED. For this one, you need to supply the code. Just supply the code. Then an essay about the differences between a microprocessor and a microcontroller. This one. Third, and this is the last part, another essay about understanding your board, your circuit breakdown. That is what we discussed together. Those three are going to be submitted as a one PDF file. One PDF file. This is my topic 1 assignment. Assignments. Topic 1 here. I have 5 assignments. Each one will be 10%. 10% because I have here how many assignments? Yes, 5 assignments. Topic assignments. This one would worth 10%. Now I go to my modules And here I'm gonna find my in-class activity. Sometimes, or most of the time, the in-class activity will be within the PowerPoint because we are doing it as we are explaining. But here I have this in-class activity under topic 1. What does it say? Would you please all open it? Do you have it open? I'll give you 10 minutes to read and think about it. Okay? Just 10 minutes. You have a nice cat. Oh. When I mean think, it means think about it and try to answer it so we can discuss it together.
Does anyone have any ideas for the last one? What they would use a blinking light for?
Sorry, what was your question?
For the last part of the assignment, for your own project, what you have any idea of what you can use this blinking light for or modify it to be useful?
I could use it for like error indication or something like that.
You
If it
send a
blinks
Morse
3
code
times,
message.
that means a certain area. Yeah. We could program a function that does Morse code. So you're adjusting variables that change the difference of how long it's held on and how long it's off, instead of having firm values.
I can give you a suggestion on that. Are you ready to hear it?
Yes.
How many LEDs do we have?
LEDs 10.
You have 10. You have 10 beside LED number 13. Can you turn on or off any of those LEDs?
Yes.
Instead of saying turn on LED pin, that is LED pin, you define LED pin as 13. I can say LED pin 1 will be 13. LED pin 2 will be whatever number. So I can have all 10 defined, and I can turn them on and off as you want. You can make them turn on in turn, and I keep on rotating the 10 pin in order, so I will get whatever you want. Clear?
That makes sense, yeah.
Could I see it?
I don't have that code, but
No, you can write the code. Can you
yes,
write the code?
probably.
Yes, I gave you one code on my PowerPoint presentation, and when you go to the PowerPoint, you can see it. Just type this code. This will be your first task. The blinking LED, you need to write this code. The next step is to modify it. So write this code. Of course, you cannot run it without having the board, but at least write it. Get it ready, and then save it and start getting a copy of this and build on it this innovative version of yours. Is it clear how to do it for everyone?
I have questions about the LEDs.
Yes.
So it's on the pinout. It said actually D8. But it's all 8, all 10 of them is like have the same pin number. How do you?
They're not the same pin number.
If they all have the same pin number, how come when you first turn on the board, they would blinking on kind of like in the rainbow color? So it have to be controlled individually, right?
Yeah, everyone will be controlled individually. Yes, yes, of course.
But then when I also define a pin D8,
you will make 10 definitions. It's not
I'm
one
sorry.
define.
Oh, is it one define?
No, not one define.
Oh.
Each pin will have its own definition. Will have its own defined statement.
Okay. So it's multiple pins number then.
We cannot define. Each pin will be defined by one statement. This statement, just a moment.
I'm still a little confused about the pin layout of that on that digital
Just
express.
please, just let me show you.
Okay.
Can you see this?
Yeah.
Define lead pin 13. This is done.
Yeah. So I got
Then
that
you go
working.
to the second line. Define. Define pin 2. This will be another number. Define pin 3. Another number. So each pin will have a line here. Each pin will have a definition. Pin mode. Pin 2 will be output. Pin 3 will be output. All of them will be defined here as a pin mode. Define them as output. Here, each one will have its own digital right. They can have the same state or different states. I can have state 1, state 2, state 3. This is up to you. I can turn them all together on.
Okay.
Let pin 1 state, let pin 2 state, let pin 3 state. This will turn them all together, but each one will have its own digital right. Then I invert the state. Now everybody will be ready to be off on the next state. The program will be bigger, of course. And you can try it with 2 or 3 LEDs. If it works, you can make it 10 or 5, whatever you like. This is up to you.
Okay.
And I am giving you until 9 to work on this and show it to me. I need to see one like this, exactly like this one, and you save it, and then you start working on your innovative version of it.
Okay.
We'll be back at 9.
Okay.
Okay.
Thank you.
Anybody need any more clarification? I'm available. Okay.
just a clarifying question. We're only working on the file named topic one in class activity blinking.docs. Or are we doing more than that?
I believe it's the topic one in class activity blinking document that he has.
It is in class activity under the modules. You go to modules, topic one, and it is the in class activity.
Gotcha. I just want to make sure.
Okay. Hello, everyone. The code for the blinking LED, you have it on my PowerPoint. And you have it also if you go to your Arduino, you open it and you go to examples under file. You're going to find examples. This is a basic example. And this is the simple version, the few lines. I prefer that you use the one I have it on my PowerPoint.
I was asking more in terms of the 10 LEDs.
10 LEDs.
Yes, because I couldn't
Are you
find the
ready?
naming
You can show
convention.
it to me now.
Yeah, I just don't have the name for those LEDs. I used D1 through D10 because I didn't see it, and then I started looking for it, couldn't find the name for it.
No, it is not. It is from you. It is, you are the one who's going to make it.
Yeah, I can share my screen, but the naming is gonna be wrong for the LEDs, I think.
Oh, the names of the LEDs. You can put any names, but you need to specify the number of the LED. The reference number, you can find it on the third, yes, the third, slide 39. Or 37, 38 or 39. 38,
yeah, I looked on
yes.
the line and I couldn't find it on the line on that slide. It names
Yeah.
all the inputs and outputs, but not the LED names.
Yeah, it uses D8, but then do we have to index them individually, or how does
No,
that
you
work
can
exactly?
even use D8. D8 will work. If I put
But will that turn them all on, or is
one,
just one at a time?
yeah.
Okay, so none of that was very clear in any of the documentation I was looking at. I was getting kind of frustrated.
Yeah, same here. I was the same issue. I was looking. I was like, how did you, where are the names? I saw the 8 as a built-in 10 NeoPixels, but I was like, okay, how do you do the rest of it? It's kind of confusing.
Can I share my screen?
Yeah.
If possible.
Yes.
I'll go ahead and share. I believe it's this. Just my Arduino code. So here I defined them D1 through D10 because I couldn't find the name anywhere.
Okay.
And then I had two states, state 1 and state, the normal state. And then I wasn't sure if we have to pin mode all of these, but I did just in case, define them all to outputs. Set my state to 0 and set my state 1 to 1. And then I just had them alternate, every other one blink on, and then the other ones were blink off or set to 0. And then I set state 1 to state, and then inverted state 1, and then repeated it.
Do you have 2 void loops?
1.
Okay. Would you go up anything?
I go up?
Yes. This is the setup?
Yeah.
Okay. Where do you specify the output?
I specified all of them as output, yeah.
Yeah, but what is the value of the first output?
Oh, I wasn't sure where to specify that. Where would I put that?
You can put them all at the very beginning 0.
Yeah, so I would do that here.
Yeah, instead of word output, you put 0.
Oh, okay.
So it will be off.
Okay, I just copied the initial. I thought it would start off at 0, but I wasn't sure because I thought state would be 0. And then I think that this first void loop would set them to every other one.
They're all output. Yes, output the condition. And pin mode, LED pin. Why is the first one input? Oh, it's output.
No. This is the LED one. I left it blinking, so this one's gonna blink.
Yeah.
Normally, and then these are gonna blink every other one. So it's gonna try to hypnotize you or cause a seizure.
Okay.
Let's check the documentation for the NeoPixels. These are actually serial. They're actually active. They're actually chained as one big shift register. On
Oh.
D8.
Okay, so I would do you like D8_1 or something?
No, I mean it's literally just one pin, and you would like shift in 20. You'd send like 24 bits in, and then the next one you'd send would go to. Then the first 24 bits would be on the first NeoPixel LED, and then when you shifted in another one, then that would be now on first, and then the previous one you'd send is now in the second one, and you just shift in that 8 times.
Oh, that
to fill up the
24 character. Okay, 24 character. So this would be just one D8. Okay.
Yeah, it's actually not trivial or actually particularly simple for us right now to address all of the NeoPixels.
Okay, then I'll probably just I'll probably have to rewrite this.
Yeah, this development board, they wrote a library specifically for this board. And with that, then you can just call the built-in functions from that library, and that's how you get the colors and everything. You can download it from their website and get out their entire library package.
That would make it much easier, wouldn't it?
With examples and all, like everything you can think of. Examples of using all their outputs, built-in sensors, everything.
Is this on the first, second, or third? Oh, you just went to the Arduino website to download the library.
I found it through the Adafruit or whatever they're called. I found it through their website for this board.
Oh, gotcha. Thank you. I'm gonna look for that.
Yeah, you need the neopixel_blit.h to use the functions of the NeoPixels.
Yeah, there are functions to change the colors, and we are going to have it. But right now, just to make it simple, just on and off. I'm sure that you have many innovative ways, and I am really so eager to see those. I hope that you can get this board as soon as possible. If possible, we can play with it on the coming Thursday. Right now, do you have any questions? Any questions?
Yeah, for turning in the assignment.
Yes.
You want them all in one PDF. So we
Yes.
can just take this Word document and then add more pages to it and just save it as a PDF and send it to you.
That's correct. That's correct.
Okay.
And regarding if you are going to make a video clip of any assignment that shows, for example, the blinking LEDs, colorful LEDs, many things. If you are in the future, are gonna do this video clip, you upload it somewhere and you add the link to me in the one PDF. One PDF, you add the link to your video clip. You put it on your OneDrive or whatever, and you just send me the link to it.
You'd prefer that over just the code?
No, this is in addition to the code. You are going to send me the snapshot of the code listing. In addition, I want to see it running. If I couldn't see it during our class period, you are going to add a link to a video clip, the video clip narrated by you. You are describing what is happening in just 1 minute or less, and you upload it to YouTube or you upload it to OneDrive, and you add the link to your PDF file. Okay.
I have a question about the board
Yes.
that we use.
Okay.
So I think I break my digital playground.
Yes.
So at first it works for a little bit, and now it just doesn't pick up anymore. So in the meantime, can I actually use another board? I have like the Adreno Mega. Can I just do?
Yes, of course. Of course, you can use the board you have as long as you know the corresponding pin number.
Okay.
If, for example, here I put in my program the LED, I called it 13. Maybe you are going to have different address, so we can use it. No problem.
Okay. Thank you.
And I believe we are going to be using the temperature sensor, the accelerometer. I hope your board would have those also.
I don't, but I can get. It's probably just for on the first week. I can get another one replaced
Okay.
in a couple of days.
Okay, no problem. Very good.
So just to clarify for each weekly thing, if we physically show you this in class, do we have to still? We don't have to put a link with our report, right?
If you show me in class, you don't have to upload anything, and I'll give you the credit.
Does this count then maybe? There's an SOS.
This is the blinking LED.
Oh no, I'll give you the blinking LED in just a second. Let me upload that.
This is the blinking LED, isn't it? This is the one I gave you. Blinking LED. One LED is turning on and off.
What I just showed you actually is something I just wrote. I'm gonna get the blinking LED in just a second. Ah, here's a blinking on and off LED.
Yeah. Yeah. This is gonna be part of your topic 1 assignment.
Yeah.
And in this case, all what you need to do is just to put a copy of the code, snapshot of the code.
Gotcha.
Okay. Any more questions? I'll be available Monday, 7 o'clock for 40 minutes. If you want to meet, if you want to discuss anything, I'm available. Otherwise, we'll meet on Thursday. I wish you a great night and see you next week. Bye now.
Thank you so much.
Thank you.
Bye.
Good night.
All right, thanks.
Thank you, Dr. Mahmoud.
Thank you, sir.
Thank
Bye-bye.
you. Bye.